Hey guys, Shanky here. Today I'm going to show you a 100% efficient reinforced iron plates factory that makes 20 plates per minute. I'll be using the original recipe for the plates here, but I will be using an alternate recipe for screws. The factory in question requires 240 ingots per minute. If you need a design to help produce said ingots, you can refer to my smelter factory, which will smelt any number of ingots you need. Link in the description. Now, the factory only takes up a 3x3 space, so it's pretty compressed. So compressed, in fact, you're going to need wall outlets to power the thing. Anyways, let's get started. We're going to start things off by placing 7 single wall conveyors as shown. The rest will be regular walls. Next, we're going to place a splitter in the middle of the foundation with another to its left. Connect the first one up using Mark III conveyors and then take one output and connect it to the single wall conveyor adjacent to it. Then we're going to use a Mark I conveyor to connect it to the splitter. Very important that you use a Mark I conveyor here. Then we're going to attach this and then place another splitter right in the center of the 3x3. We'll connect the second splitter to this with Mark I conveyors. And then place 2 more splitters on both sides of the center splitter and then connect them up. Each socket here is going to a separate constructor to produce screws. All except one constructor needs 12.5 ingots per minute. The one on the bottom right needs only 10 ingots per minute as we will be underclocking it to 80%. The 240 ingots come in and get split into 60 and 180. The 180 will be used later for the plates. The 60 is split into 30 and 30. Since this line only needs 10, it will back up till the conveyor. At this point, the rest of the feed rate, which is 20, will move to join the other 30 at the center splitter to become 50 ingots per minute. This is then split twice into 25 and then 12.5. Cover the floor up. Place 5 single wall conveyors on top of the conveyor lines from the previous floor. Place a constructor for each conveyor wall and connect it up with the lifts and belts. Underclock and assign the work. Then place mergers with the direction going away from the single wall conveyor from the previous floor. This will produce a total of 240 screws, so just use a Mark III conveyor to connect it all up. Saves time. Then extend the conveyor to the edge here. Place 2 rows of windows and then cover it up. Next, place a single wall conveyor on the same side of the ground floor inlet and single wall conveyors on both the other sides. And cover the spaces with regular walls. Next, place 2 splitters, one in the center of the first foundation and then the last foundation of the middle column. And 2 more on either side in between the 2 foundations. Then connect them up. Now bring the 180 screws from the ground floor and connect it to the inlet using a lift. $180 is split 3 ways to get 60 and then split again to get 30. Cover it up. Now place single wall conveyors on each side of the building in line with the conveyors of the previous floor. And then place a constructor for each wall. Connect up with the lifts and belts. Next, place the mergers, this time in the direction towards the inlet on the previous floor, or in the opposite direction of the mergers from the previous set of constructors. The total number of plates produced only amount to 120, so you can just use Mark II conveyors here and not Mark III like I am. Again, bring the last conveyor out to the edge. Place windows and cover it up. Here you can place windows like I am. This is totally just an aesthetic thing and serves no other purpose. Now place a single wall conveyor in the center and double wall conveyors on each corner like this. Fill the rest of the spaces with regular walls. Then place a splitter in the center, with two other splitters on either side. Use Mark II conveyors to connect all of them up. And then bring the plates from the previous floor and connect it to the inlet. Here, 120 plates per minute is split twice to get 30 plates per minute for each assembler. Cover it up. Now place a single wall conveyor on the opposite side this time, and then place the double wall conveyors just like the previous floor. Place a splitter in the center and two others on either side. This is for the screws, so use Mark III conveyors. Also, make sure to connect the conveyors to the sockets that aren't on the same side as the previous floor, otherwise you're going to overlap them. Then bring the screws up with a Mark III lift. Here 240 is split twice to get 60 screws per minute for each assembler. Cover it up. Move to the right or left, doesn't matter, and place two double wall conveyors in line with the previous floors and place an assembler for each one. Then connect with the lifts and belts. Now place a single wall conveyor in between the two. Place the merger in the center with the direction of the output towards the single wall conveyor. Connect it up with Mark I conveyors. Place windows and cover it up. Repeat the same process for the next floor, but this time place a double wall conveyors on the other side and go from there. When placing mergers, place them so that they flow in the direction away from the inlet on the ground floor. Then, use a lift to bring the reinforced plates from the previous floor to the top floor. And connect with the merger. Now cover it all up. Now, just bring the total output from the top floor to the bottom, or go up if you'd like. As you can see, the graph is a straight line indicating 100% efficiency. Thank you so much for watching, guys, and I'll see you guys next time. If you're new here, welcome and consider subscribing. I'll be posting more builds like this, so stick around. I also make guide videos, so go check them out.